Okay, and here we go. Chapter 7.4 notes, the other trigonometric functions, page 14, the final page. So we want to simplify these using our trig identities. Secant, we know, is 1 over cosine. Tangent is sine t over cosine. Just a reminder of why things work the way they do. If we're dividing by sine t over cosine t, we're multiplying by cosine t over sine t. We get 1 over sine t, which is cosecant t. B, we get sine t, cosecant is 1 over sine t. I've got cosine t over 1 over cosine t. So divided by 1 over sine t means times sine t. So I get sine t times sine t, sine squared t. Cosine t times cosine t, cosine squared t is equals 1. C, 1 minus sine theta times 1 plus sine theta. This is going to come in really useful. We are going to use the distributive property or the FOIL method to multiply these. 1 times 1 is 1. I get plus sine theta minus sine theta minus sine theta times sine theta is sine squared theta. So I got 1 minus sine squared theta. And if we remember back to our Pythagorean identity, cosine squared theta plus sine squared theta equals 1. We can subtract sine squared theta from both sides, and 1 minus sine squared theta equals cosine squared theta. D, this one looks a little overwhelming, but I'm gonna use what I just did on C. So I got sine squared x minus cosine squared x. The 1, I'm going to go ahead and rewrite as sine squared x plus cosine squared x. Still have this minus, this was minus 2 cosine squared x in the denominator. So I've got sine squared x minus cosine squared x. In the denominator, I've got sine squared x plus cosine squared x minus 2 cosine squared x gives me a minus cosine squared x. And the same thing in the numerator and denominator, that equals 1. Cotangent theta over cosecant theta. Cotangent is cosine theta over sine theta. Cosecant is 1 over sine theta. Both numerator and denominator over sine theta, we could see like example A, where that inverted and multiplied and those canceled out. This just becomes cosine theta. F looks kind of like C, so we're going to start by just multiplying that out. I get secant squared x plus secant x minus secant x minus 1. That gives me a secant squared x minus 1. And if we go back, we had 1 plus tangent squared x equaled secant squared x. So secant squared x minus 1 equals tangent squared x. Probably keep track of these answers, huh? Cosecant, 1, we've got a 1 here. Cosine squared, cosine theta, tangent squared theta. Okay, sine negative t, cotangent negative t. So first thing I'm going to do is rewrite cotangent as cosine over sine. Our sines cancel. We've got cosine of negative t because that is an even function. The same thing as cosine of t. And h, the very last one. 1 over cosine squared x. Cosine squared x is secant squared x. And if you take a look at f right above us, this is just the opposite of what we had right here. So the opposite of tangent is negative, tangent squared x. Like I said, these may look a little different, not exactly the way you have them in those Pythagorean identities. You should be able to figure that out though. And that is it.